Alright, today, ladies and gentlemen, we're going to be talking about some properties of logs, okay? I will be posting this worksheet up for you guys to see and try and write down some of these on your own. There's going to be some extra problems in here as well for you guys to try. So, see what you can do. Follow along here if you want. Alright, so, properties of logs, right? So we have some basic properties here. There's a bunch more. Some of these should be obvious. For example, the log base b of 1 is equal to 0. Of course, that is because b to the 0 power is equal to 1. Now this is, of course, as long as b does not equal 0, because we know 0 to the 0 power is undefined for our purposes, okay? So, first one, nice and easy. Anytime you have the log of 1, it equals 0, and it is because anything to the 0 equals 1. For number 2, log base b of b is equal to 1. That, of course, is because b to the first power is just equal to b, right? Now, properties 3 and 4 are kind of important. You're going to be using them in the first web work a bunch, and this basically just says that log base b and b to the x are inverses, and they end up canceling out with each other, right? Anytime you compose inverses, they will cancel, like this. So I'll do an example for you, a couple examples throughout this packet, but let's just consider log base 2 of 2 to the negative 3/8. This log base 2 and 2 to the negative 3/8 are inverse operations of each other. And basically, you're going to raise 2 to the 3/8 power, and then you're going to say 2 to the what equals that new expression? Well, of course, that's just equal to negative 3/8. And as I said, the log and the 2 raised to the power cancel. Okay? Same thing for problem number 4, right? It's just composed in the opposite way. Base raised to the log base b of x is equal to x. Of course, we need to stipulate here, that is, if x is greater than 0. That is, x has to be in the domain of log in order to make that work. So, as an example, I could say 10 to the common log of 57, right? So now the common log of 57 says 10 to the something equals 57. I don't know what it is, but there is an exponent that will take 10 and turn it into 57. Now raise 10 to that power, and what do you get? Obviously, you're going to get 57. Because the log equals the exponent that turns 10 into 57, and then you raise it, okay? Now the other way to think about this is that these are inverses. 10 raised to a power and log base 10 are inverse operations, and they cancel, giving you just 57. Of course, that's as long as 57 is greater than 0. Okay, so those are two important properties. Now we're going to do a multiplication property, a division property, and a power property. Okay, these come from the multiplication, division, and power properties for exponents. So this one here says the exponent that you would have when you do the product, right? Log base b of a product is going to be equal to the sum of the individual exponents. Okay, so that is, you know, log base b of m times n is equal to log base b of m times log base plus log base b of m. If I wanted to prove this, all right, or to show it, what we would do, we would say, let's let log base b of m be equal to, say, x, and the log base b of n be equal to y, which means that b to the x is equal to m, and b to the y is equal to n. So m times n is equal to b to the x times b to the y, or b to the x plus y. And that's by the multiplication property of exponents. All right? So when we say, what is log base b of m times n, we would say, well, b to the what power equals m times n, and we know that that b to the what power is x plus y. But of course, what is x plus y? Well, x is log base b of m, y is log base b of n. That gives us log base b of m plus log base b of n. So this follows directly from the exponential property of multiplication. And of course, you could do the same kind of thing for division and a similar type argument for a power. So a product inside your log splits up into addition. Division inside your log splits up into subtraction. Remember, logs equal exponents. So what do you do with exponents in division? You subtract them. What do you do with your exponents? The logs equal the exponents. In multiplication, you add them. And then here we have a power property, right, that allows us to take an exponent and bring it down in front as a coefficient to the log. So for example, log base 2 of 2 to the negative 3/8. Another way we could do this is to bring the negative 3/8 out in front. And then from the earlier property, what's log base b of b, or log base 2 of 2? Well, that's just going to be equal to 1, giving you negative 3/8 also. Okay? All right. Last two properties here. This one is for solving equations. We're going to do more of this next week when we solve equations. And this change of base property I'll talk about also next week. This is going to be able to allow us to evaluate logs. And in fact, some of you may have seen it in the last web work. If you were trying to calculate, let's say, log base 9 of 2, and you went ahead, and you hit the button for log base b of something in like the web work function notation stuff, how they do, what you would have seen if you hit that button is log of something divided by log of something. All right, and that's a common log, or you could use a natural log, or really any base that you'd like to, that this could be evaluated as log of 2 divided by log of 9. All right, so if you're using your calculator now, you can use natural log or common log to basically calculate any log of any base. Using it now, your calculator does have a log base function that's under the math options. You can go down to the bottom, scroll down to the bottom of the list, and get that. Well, now you know how you can possibly calculate a log using this change of base formula. Okay, as I said, we'll do more with this next week. So now, let's just practice a couple of these. I might do a page or so, and then we can, you can try some of the web works for the week, because that is what is coming up.